Okay, so we are working on a summative review. Hopefully we started working on this in class already. So I'm going to give you the answers to the transformation part of your summative review. Let's see. So this is a state task, and I'm going to show you how to work it out. I will not be moving all of these points on here. Most of them I'll just go through and show you how to how to read the ordered pairs. So the direction says draw a rectangle, parallelogram, square, or isosceles trapezoid in the coordinate plane so that the portions of the shape are in each 4 quadrants. Explain what would happen to your shape if you transform it using each of the given rules. So they just want you to give an explanation. You don't have to actually do the transformations. So here, I'm just going to draw a square, make my life easy. And I'm going to call this A, B, C, and D. Now, some of them I will show you how to move, but others I won't. And I'm probably going to have to take a picture of this so that the screen's going to move. Let me grab a picture of this right quick, and we will keep it moving, babies. Okay, I copied it. No. Okay, let me go down here, edit, and we are going to paste. Okay, so I got what I need. Here's my picture of what I drew, and I'll just keep this along because I know this is going to move. Okay, so here, I need to clear the page. Here's my picture that I have, and right here, if you notice, it said that take a negative x and keep the y positive. So I'm going to use my A, and I'm going to say that's 1, 2, 3, 4, 5, and 6. Let me move this picture over. So that's 6. So I'm going to say negative 6. So if I look at A, that's negative 6 and 1, 2, 3, 4, 5, 6. Negative 6 and 6. And I'm going to do what this say. Let me go ahead and write my B down also. My B is, that should be 6 and 6. And my C is negative 6, negative 6. And D is going to be 6 and negative 6. All right, so now we're going to get our A prime, B prime, C prime, and D prime. So you can see what's happening. Now, I already know what this is going to do, but I didn't formally teach you this way, so I'm showing you how to figure it out. So my A prime would have to be take the opposite of X and leave Y alone. My B prime would take the opposite of X, leave Y alone. My C prime would be take the opposite of X, leave Y alone. And my D prime would be take the opposite of X, and leave Y alone. So that means 6 positive 6, this would now would be A prime. This would now be B prime. This would be D prime. And this would be C prime. And if you notice, I just flipped. So this was nothing but a reflection over the y-axis. So when you do a reflection over the y-axis, the x value changes, but the y stays the same. The x value takes its opposite value, and the y stays the same. So here we're just going to simply write that was a reflection over the y-axis. Okay, and it's the same logic here. If you go through and do the same thing, this time we would flip over the x-axis. If I flip over the x-axis, the y value changes and the x stay the same. The y value takes its opposite. So this is a reflection, and you can always graph your pre-image and just do what it say. Reflection over the x-axis. All right, this is to the right 3, and the y stays the same. This is down 2. The x stay the same. This is left. Oops. This is going to be left 1, up 4. This is going to be a dilation where k is equal to 2, and we're going to get an enlargement. And I can say that because both letters are being multiplied by 2, so the scale factor is 2. If I do a negative x, negative y, that is nothing but 180-degree rotation. Or you can say a reflection over the x-axis and then a reflection over the y-axis. Okay, I'm going to clear the page. The next one, here, you're going to have a horizontal. You're going to have a horizontal stretch by a factor of 3. And then you're going to go to the right. Oops, and I'm putting left. Hold on. You're going to go to the right 2, and then you're also going to go down 1. And you finish. And we know this one here won't create congruent figures because we stretch the x and not also the y. Okay, so let's keep moving. It says, which of the transform figures are congruent to the original figure? So if you look at all these, we're going to say 1 through 7 because they are rigid transformations. And we're done with that one. Okay, let's keep going. It says which transformations are not congruent to the, wait, I'm sorry guys, it's not 1 through 7. It's 1 through 5 and then 1 through 5 and then 7, because 6 and 8 are not rigid transformations. 6 is a dilation and 8 is a horizontal stretch, which makes the picture only stretch out on one side. So go back and correct that. It says which one is not, and we'll say 6 and 8. 6 because it's a dilation, and 8 because we have the horizontal stretch. Now you finish with that. All right, let's keep going. Number 11. And I would try these on my own first, so hopefully you've already done that because this is really good practice. Okay, it says if you make a new figure by adding 2 to the x and y coordinate of each side of your shape, will the figure be congruent, similar, or neither? So it's telling you to take each one, to take x plus 2 and then y plus 2 to each side of your figures of your coordinate. This is going to be congruent because a translation is a rigid transformation. It's a rigid transformation. All we did was add 2 to each of the sides, so that's not changing anything. Okay, let's keep going. Number 12 says create a rule for the set of 90-degree rotations. Explain how you decided the rules. Well, we already know the rules. If we have x and y and we go 90 degrees, if we turn it 90 degrees, then we know we switch x and y, make the x negative. If we have x and y in the second coordinate quadrant, then we're going to end up with, if we keep moving to B, we're going to end up with negative x. Oh, it said 90 degrees. I'm sorry. All of these rules are going to be the same if we move it 90 degrees. So y, negative x, x, y. And they actually wanted you to write the points. but I'm just showing you the rule because we already know it. And these points would end up here. X, Y would be Y, negative Y. And you notice that the X and Y would have switched and the X would have been negative. Same thing if you put all these points in this place. Okay. All right, it says, will a 90-degree rotation of any shape create a congruent or similar figure? And we're going to write, they're going to be congruent because rotations are rigid transformations. All right, what general conclusion can be determined? What general conclusion can be made determining which transformations will produce congruent figures in the plane? So all you have to say, as long as the coordinates are not multiplied by a scale factor, then are not multiplied, then the figures will be congruent. It will be congruent. And you're in the game. Okay? All right, let's keep going. Number 15 says to describe transformations or series of transformations that will transform your figure onto itself. Explain how you know this will map the figure onto itself. There are plenty of things you can say. Mapping onto self means that you can put a line of symmetry on your picture, and with my square I actually have 4 lines of symmetry, but only 2 that I can talk about. So I can say there are 4 lines of symmetry, but there are only 2 you can write, which is Y, the Y-axis, and the X-axis. And the ones that are diagonal, don't worry about. You don't know how to write those yet. And you can say, you can rotate about the point 0, 0. So find my center of rotation, and since that's a regular, my polygon looks like a regular polygon, it's a square, and I drew it that way on purpose. We can say the points of rotation is 90, 180, and 270. And where I get these numbers from, I did 360 divided into 4 is 90, and I just kept adding 90 until I got all the turns that will put it on top of each other. And you can always take a sheet of paper, trace this, turn your paper, hold it in the middle, and see if it'll turn. Or see if it can turn. All right, let's see what's next. It says describe the transformations that would make one side of the image parallel to a corresponding side of the pre-image. Why would these result in parallel lines? So this means a translation is happening. If I slide this down, and it becomes A prime, and this becomes B prime, and this becomes, how many did I go down? 1, 2, 3. So 1, 2, 3. 1, 2, 3. If I slide this down and this becomes C prime and D prime, then the lines that I slid this down would be parallel. It says describes transformations that would make each of the image parallel to the corresponding side. Okay, so not only do I have to send it down, I actually have to shift it over too, because I want this to be parallel to its corresponding side. So you do a translation And you can just do a translation to the left or to the right, or you can go up or down, and I'm going to show you. I'm going to say and, up and down. Let me show you what I mean. So I could take A and I can slide it over and I can slide it down. So I'm going to do the same thing here, over, down. For B prime, over, down. How far did I go down? I went 2 down. Over 2, down 2, over 2, down 2, over 2, down 2. All right, so this becomes C prime, D prime, A prime, and B prime. And if you notice, it said it wanted the corresponding sides parallel to each other. And if you look here, my corresponding sides are parallel. So all I have to do is do a translation. And they're parallel because they're not going to cross over each other. Translations, when you do a translation, the points do not cross over each other. Translations produce parallel lines. Produce parallel line segments. Okay, that's the answer to that one, and let's keep going. It says describe the transformation that will make each side of the pre-image perpendicular to the corresponding side of the pre-image. Okay, so here, I'm going to leave that one for you. Bring this one back for extra credit. Let me see which one you can figure that out. Okay, and let me see if I have another. That's a good one. Go ahead and take your time and figure this one out. And then come back if you show it to me and it's correct, I'll give you some extra credit. That's a good thinking one. All right, bye guys.